Hello dear student, this is Professor Rasaf Kumar and I welcome all of you to my video lectures. Today's topic is chapter number 3 and topic name is the velocity and acceleration analysis. Basically this chapter contains somewhat larger topics and subtopics, that's why the entire lecture, or we can say that the entire chapter is divided in three parts, part 1, part 2 and part 3. And of course, as you know that this chapter velocity and acceleration analysis comes in subject kinematics and theory of motion. Generally this subject is offered by university in 5th semester degree mechanical engineering. So let's start our first topic, and that is an introduction. As you have seen my previous video lecture, we have also discussed that in any particular mechanism, if one link of the mechanism is given some specific motion, the motion of the other link is either completely, or we can say that they are successfully constrained. In simple way, we can say that each link of the mechanism is subject to some definite displacement, velocity, or we can say that the acceleration at a particular periodic time or an instant. So suppose you are giving an initial displacement, or we can say that the initial velocity to any link. Of course there will be a relative motion to other links also. Particularly in this lecture, on the base of that content, we will determine the velocity and acceleration of various links present in mechanism. So entire chapter will be focused upon the calculation or determination of velocity and acceleration. There are numbers of methods which are being used for the determination of velocity and acceleration of the various links of the mechanism, like relative velocity and acceleration method, instantaneous center method is there, plane construction, analytical method through which you can also calculate the velocity and acceleration of various links, complex algebra method as well, vector algebra method. So there are the 6 kind of method or the procedure through which you can have the calculation of velocity and acceleration of various links. Now before calculating the various links, velocity and acceleration, it is very important to discuss and learn actually what is the linear and angular velocity. And to understand it clearly, kindly consider the screen. You have given one body and which is displaced along a straight path. So we can say that body moves from A to B center instead. So the body is displaced. So we can say that the displacement is. Now we know that as it displaces from A to B center, of course the displacement unit as unit of displacement is meter or mm. Now if such a displacement that has been moved, or we can say that the body is moved from A to B through S displacement, if you are deriving the relation, or we can say that if you are measuring the displacement with respect to periodic time, it will be known as a velocity. So generally we can say that the rate of change of linear displacement of a body with respect to time is generally known as a linear velocity. Again, mathematical relation for linear velocity is what I said earlier. It is the differentiation of the displacement with respect to time. So we can say that the rate of change of displacement with respect to time, that will be the linear velocity. Over here there is a linear velocity because we know that whatever the displacement is done by the body from A to B is the kind of linear displacement. So whatever the velocity you are measuring with respect to time will of course the linear velocity, and SI unit for the linear velocity will be mm per second or say meter per second. Now just consider one link OP1 and the outer surface of that particular link. There is a point P1 which is moving in angular displacement through S. Now when body is displaced along a circular path, then it is generally we can term it as angular displacement. So if you are considering link OP1 which rotates about the center O, and it is inclined at angle theta with the horizontal or say x-axis. Then link OA move by angle theta in some periodic time, say t. So whatever the change of that angular position of the link OP1 to OP that is made by the particular point P1, if you are measuring with respect to time, that will be known as we can say that the angular velocity. So rate of change of angular displacement with respect to time, that will be the angular velocity. If you are measuring the rate of change of linear displacement with respect to time, that will be the linear velocity. So mathematically angular velocity will be the omega, and that is equal to d theta upon dt, where d theta is the, we can say that the change of angular displacement d theta, and dt, that is the time required to change that angular displacement. And now unit for the angular velocity is of course radian per second. Now it's time to discuss the various methods which are being used for the determination of velocity and acceleration of various links which are joined in particular mechanism. First and very much important type of the method that you have given, that is the relative velocity method. Particularly in relative velocity method, the mechanism is represented by a line diagram, and its link is centrally highlighted by a straight line, and which is known as a configuration diagram. Now by using this configuration diagram, you can draw the velocity diagram called velocity polygon, and by making use of velocity diagram, you can also find out the velocity of link for a given mechanism. Now look at the screen. You have given kindly consider a particle A that is moving with an absolute velocity VA. Now consider another particle point B which is also moving with an absolute velocity VB. Then the relative velocity of particle B relative to the particle A will be termed as V suffix BA. And whatever the velocity, relative velocity of point or particle B with respect to A, it will be always we can say that represented as a VAB. So this is some notation specially given to the various particles which are moving on links. Now we all know that the velocity is the kind of vector quantity, so we can say that the velocity with respect to particular point, that means VBA or VAB, also kind of we can say that a vector quantity. So by definition, relative velocity of various points, like it will become V suffix BA is equal to VB minus VA, or we can say that the VB is equal to V suffix A minus VBA. Or you can also write this relation in terms of vector quantity, like vector small OA is equal to vector OB minus vector OA, or you can write like vector OB is equal to vector OA plus AB. Basically it is taken from the velocity triangle. And look at the screen first. This is the point through which this velocity of particle is represented. So triangle OEC, in which specially VA represents this velocity component, whereas VB represents this velocity component. If you are joining both of the velocity component, then we can say that the third side of the triangle will represent velocity of B with respect to A. And similarly, you can follow the same for the triangle OB and A. Similarly, the velocity of B with respect to A may be calculated by using the law of parallelogram of velocity like that. First of all, apply the velocity VA, which is equal and opposite to particle A and B. So you are getting the relation like OC is equal to VB and OD is equal to minus V. And ultimately by doing so, you will have the resultant like OE is equal to VBA, and that is equal to VB minus VA. Now sit at the point O to represent the zero velocity point. Draw a vector OA which is parallel to VA and OB parallel to VB by taking some suitable scale. So over here vector AB, that means third side, that is equal to VB minus VA, and ultimately it will be equal to vector OB minus OA. So this is the step 1 and 2 that we have already discussed in previous slide, that how you can generate a triangle by keeping the direction and magnitude same for the various velocity component like VA and VB. So both of the side will be connected, and the third side will connect both of these vector VA and VB. So third side will represent related component of velocity. After that, point number 4, that is the velocity diagram of a rigid link. So particularly this point will highlight about the velocity diagram that required to be drawn for any kind of rigid link, because we know that if there is a 4-bar chain mechanism or slider crank mechanism or any kind of the mechanism, at least one link is having the fixed position, so we term it as a fixed link, whereas in some instant you are also finding that the rigid link is to be considered for the analysis purpose. So what should be the velocity diagram, and how one can have the drawing of the velocity diagram for that rigid link, that will be discussed in particular these topics. Now look at the screen. Kindly consider a rigid link AB that you have given to your screen, of which have the fixed length AB. And now let the absolute velocity of point A will be the V suffix A, and to which magnitude and the direction both of are given. Now the velocity of VA will be represented by vector OA. That means if you are finding vector OA, then look at the diagram, that is the O, and that will be the OA. So this represents the velocity of link AB, because it can be drawn easily because direction and magnitudes are known to us. After that, assume that the motion of B is in the direction, that is, look at the diagram first, shown in the figure, and its magnitude is not known. So in this case, magnitude of velocity of point B cannot be fixed, because it has a relative motion with respect to point A. So B can be only moved relative to point A. This is the fact, because magnitude is not given, only direction is given, and that way we can have the fixed center A as the point A, and B are at fixed distance. B is located at a fixed distance apart. So in that way we can have the fixation of point A and B. Now VB is in the direction that you are looking for in this particular velocity diagram, and it is represented by O and B. So this is the velocity of the link B, which is represented in velocity diagram. Now the third side, that means the point AB, or link joining the point AB, is representing the velocity VBA, and it is obtained whenever once you are joining these two lines OA and OB. So this is what I have discussed earlier, that if you have the two sides known to direction and magnitude, of course third side will represent the resultant velocity vector of that particular link. And then now draw the line from the point O in the direction parallel to the given direction of velocity of point B, and another line from the point A in the direction perpendicular to line AB. So ultimately intersection of these lines fix the point B in the velocity diagram. Just you have to extend this line and this line, both of the line will intersecting over here. So ultimately it will give some fixing point, and it should be noted with a small point B. So ultimately in that way we can complete the entire triangle, velocity triangle OAB. So we can say that the entire triangle OAB represents the velocity diagram for the rigid link. Now it's time to have the determination of angular velocity of link AB, and for that we know that velocity of B with respect to A is represented by vector AB in the direction perpendicular to link AB. So at point B, in circular arc about point A, mark VBA like that. Once you are getting the magnitude of VBA, then from the formal relation of linear velocity with that of the angular velocity, you can use VBA is equal to WBA into length AB. So if you are converting this relation in terms of the vector diagram, or we can say that in terms of vectors, and ultimately the VBA will be replaced with AB as well. Omega BA is remain omega BA, whereas length AB, if you are measuring that, you will have that you can convert this entire relation in terms of the angular velocity of link B with respect to link A. Then velocity image, in order to find the velocity of point C on rigid link, you just focus upon point C, and by using the vector diagram you can also find the other velocity component of various points which are located on the links. Now kindly consider a point C and which is located on particular link AB, and you require to calculate the velocity of point C through exactly the velocity triangle that we have already done for the calculation of VBA. So same procedure you have to follow, but over here there is a little difference. Just make the entire link AB and divide it in such a way that the relation becomes AC times CB is equal to capital AC same CB. That means over here the ratio between the links like AC times CB, that means this AC and CB, if you are dividing both of the dimension, which should be always equal to the ratio of geometrical dimension AC and CB. So in that way, first condition, in order to calculate whatever the point given on any kind of the link, and you require to have the determination of velocity and acceleration, you have to take any ratio, and this ratio should be satisfies this basic division rule. Once you are dividing this link and vector through similar proportional, it is very easy to calculate the velocity of C. Now you can convert this ratio in particular vector form, so it will give us the relation like AC vector is equal to AC upon AB into AB vector. Of course, VC, that should be equal to VCO, because velocity of C with respect to point O we require to calculate in case of velocity polygon, velocity triangle. So ultimately it will give us a relation like VCA upon VBA, and that is equal to double omega CA into CA upon omega BA into BA. So ultimately we can have the velocity ratio of point C with respect to velocity ratio of point B, that means VCA and VBA. Now similarly you can have the ratio between point B and C like AC upon AB is equal to CA upon BA. That means this ratio is taken from on link and from triangle vector triangle. So you can write the relation like AC upon AB is equal to CA upon BA. So convert this relation in terms of the AC, you will have the CA upon BA into AB. So by following same procedure, you can have the calculation, or we can say that the determination of any point which is located arbitrarily on link from the either distance or we can say that which are located at any place on link. You can easily determine the velocity and acceleration. After that, one more method for the velocity and acceleration determination is the instantaneous center method. Basically this method is based upon the concept that any displacement of body, or we can say that the rigid link having motion in one plane can be considered as a pure rotational motion, and of course if you are considering so, you can have the very easy to define the velocity and acceleration of various points. So once you are considering that the entire link as a rigid body and it has the pure rotational motion as a whole, some center is required, and that center will be known as instantaneous center or virtual center, because if you are rotating link, of course this link will rotate about some fixed point, and that fixed point of course will be known as an instantaneous center. Now a body having motion in plane can be generally considered to have a motion of rotation as well as translation. It may be possible that there is a combination of translation and rotational motion. So again there is a question whether the translation motion should be considered or not. But well, in case of you are using instantaneous center method, kindly consider entire motion of link as a pure rotational method. For example, consider link AB, and that you have given, look at the screen first, you have given link AB and consider its motion. Motion of link AB can be considered first as A1 to B1 dash, like that, and then turning this link to A1 B1, this means A1 to B1. Now consider nearby figure that you have given. Motion of link AB to A1 B1 can be considered generally is the combination of two motion. One is the combination and followed by the translation motion. So practically we can say that the motion of link AB is the combination of translation and rotation, but it is not playing so much importance whether the motion of rotation is given to you or the translation takes simultaneously or not, because in that particular method you have to take only the pure rotational motion of any link. Still, the motion of rigid link can be considered as a pure rotation at a particular instant with its center of rotation. We can say that it will be treated as an instantaneous center method. Now this center of rotation, or we can say that instantaneous center method, lies on the perpendicular distance of the chords AA1 and BB1. So perpendicular distance AA1 and BB1, that you have to draw on two lines from this AA1 chord and BB1 chord. Whatever the intersecting point that you are getting, it will be nothing other than an instantaneous center. So therefore we can conclude that the displacement of any rigid body, or we can say that the rigid link having motion in a plane, can be assumed as a pure rotational motion, and whatever that pure rotational motion that we have assumed is performing about some particular fixed point, and that point will be known as an instantaneous center or center of rotation. Now again consider rigid link AB that you have given, and let's have the VA and VB, the absolute velocity of point A and B on the link. Now it is assumed that the velocity of A is known both in magnitude and direction, while velocity B is only known to its direction. There is no magnitude of velocity B that you have given. Now omega will be the angular velocity of link AB. So the instantaneous center I of the link AB at this instant can be determined by drawing perpendicular lines from the both of the chords, and in that way you are getting intersecting point, and that point will be generally, we can say that it is an instantaneous center method. So again you have to relate the linear velocity with angular velocity, so it will ultimately becomes relation linear velocity VA is equal to omega into the length of I and A, that means instantaneous center and point A you have to measure, and that will be represent the distance, or we can say that the distance between instantaneous center and point A. So from that relation you can easily calculate the angular velocity of a point A, and that will be equal to omega is equal to VA, that means linear velocity of a point A upon I into A, that is the distance between instantaneous center and point A. Similarly for the point B, if you willing to have the linear velocity calculation, just use the relation between linear velocity and angular velocity, like VB is equal to omega into IB. Put the values of omega that we have already calculated in this relation, so ultimately your equation will become VB is equal to VA upon IA into IB. So we can say that by simplifying that relation, you can have the VA upon IA is equal to VB upon IB. IB will be 2 over here, So ultimately in that way we can write the general equation, that is VA upon IA is equal to VB upon IB, that is equal to VC upon IC, and that is always equal to angular velocity.